Okay, so this is problem number 3 from exam 1. Here we are given a differential equation, x times y prime plus y equals xy to all raised to the 3/4 power. And we're also given the initial condition where x is greater than 0, y of 1 equals 16. So looking at this differential equation, we can tell that it is a first order because we have a y prime and nothing else. So we have a first order. We can also tell that it is nonlinear because of this x, because there is a y raised to the 3/4 power, making it nonlinear. And we can also tell that it is a homogeneous function because we have no standalone functions of y, a homogeneous differential equation. Okay, so looking at these characteristics and looking at the differential equation, you can kind of see that it resembles maybe Bernoulli's method. If we look at Bernoulli's method, it says dy over dx plus p of x y is equal to f of x y to the n power. And if you look at this, this differential equation and this differential equation, they kind of resemble each other, and you might be able to get this to look like that. So what we're going to do is try and manipulate this differential equation, get it into this form, and solve it. So first, to do that, let's divide by an x to get y prime by itself. If we do that, we would have y prime plus 1 over x y is equal to, let's separate these, x to the 3/4 to times y to the 3/4 over x. Simplifying that, we can just write that as x to the negative 1/4 times y to the 3/4, bringing that x up. Okay. Next, we can get this x by itself by dividing by a y to the 3/4 power on both sides. So doing that, we would get y to the negative 3/4 over here, because it would be 1 over y to the 3/4. Bringing that up, it would be a negative 3/4 power times y prime plus 1 over x. We have a y divided by a y to the 3/4, and if you think about this y as having a power of 4 over 4, and then subtracting a 3 over 4 power, we would be left with 1/4 power equal to x to the negative 1/4. Alright, and now the next step in Bernoulli's method is we want to look at this term right here and see if we can do some sort of substitution, maybe manipulate this term, this differential equation, to resemble some sort of substitution. And by doing that, we're going to multiply this term in particular by 1, but in the form of 1/4 over 1/4. So let's try that out. We get y to the negative 3/4 y prime plus 1 over x, and then here we're going to multiply by 1/4 y to the 1/4 over 1/4, and equals x to the negative 1/4 power. So looking at this term, looking at this in particular, this part right here, we're going to pull this out over here. Something neat about this is that if you bring that 1/4 up, it'll be 4y to the 1/4 power, and if you took the derivative of this, it would equal y to the negative 3/4 power. And coincidentally, this is the same term as over here, which would make this substitution possible and great. So if we look at this term, we will take this as our v prime, and then what we did over here as our v. So substituting the v's in, we'll rewrite our differential equation as v prime plus 1 over x times 1/4 v is equal to x to the negative 1/4. As you can see, we just substituted v in for this and v prime in for that. And now that we have it in this form, we can look for an integrating factor. And we know that our integrating factor is going to be equal to e to the power of the integral of p of x dx. And we know that this is going to be our p of x. Here, I'll write that down here. So this is going to be a p of x. We can find our integrating factor. We do e to the integral of, let's do 1 over x, and bring the 1/4 out over here, dx, which would give us e to the 1/4 natural log of x. And with using log properties, we can take this coefficient 1/4 and raise it to be the power of x. So it'll be e to the natural log of x to the 1/4 power. Our e and natural log cancel out, which leaves us with x to the 1/4 power. Okay, so now that we have our integrating factor x to the 1/4, we are going to multiply our integrating factor by each term of the differential equation right here. So doing so, we would get x to the 1/4 times v prime plus x to the 1/4 over x times 1/4 v equals 1. Multiplying x to the 1/4 times x to the negative 1/4 will give us x to the 0, x to the 0 will give us 1. And then simplifying this, we get x to the 1/4 v prime plus, we're just simplifying this term really. We get x to the 1/4 power divided by x will give us x to the negative 3/4 power times 1/4 times v equals 1. And the interesting thing and the coincidental thing about this is that this term, if we look at this term right here, pull it out over here, if we take the derivative of this, we're going to get 1/4, it's the product rule, so we would get 1/4 x to the negative 3/4 v prime, or v, plus x to the 4th times v prime. And interestingly enough, this is exactly what we have here. If we look, we have our 1/4 x to the 3/4 right here, v, right here, plus our 1/4 x to the 1/4 v prime. So interesting enough, and what we can do with this now is take this whole thing right here to be x to the 1/4 v prime, because x to the 1/4 v prime equals what we have. And then we set that equal to 1, of course. And what we can do here is integrate. And with respect to x on both sides, we will get, with this, integrating this, we will have x to the 1/4 v. We're basically, this integral is canceling out this derivative, basically, is equal to x plus c. Since it's an indefinite integral, we have to have our constant. And now, with this, with what we have here, we can back substitute our v, because we can't have a v in our answer. So we'll back substitute, and if you remember earlier, we took v to be y to the 1/4 over 1/4. So let's back substitute our v. That'll give us x to the 1/4 times y to the 1/4 over 1/4 equals x plus c. Now just simplifying this even more, we'll write it as, we'll bring that 1/4 up, and we can write it as 4, bringing this 1/4 up, y to the 1/4 equals x plus c. And now we pretty much have it all solved. We just have to use our initial condition, which is y of 1 is equal to 16. And using that, we will substitute our y's to equal 16 and our x's to equal 1. So we'll have x, or 4 times 1 to the 1/4 power times 16 to the 1/4 power is equal to 1 plus c. 1 to any power is 1, times 4 is 4. 16 to the 1/4 power would be 2. And this will give us 8 equals 1 plus c. And if we do 8 minus 1 on each side, we would get 7 is equal to c. And now we can write our solution. 4x to the 1/4, y to the 1/4 is equal to x plus 7.